Synopsis of The Structure of Scientific Revolutions by Thomas Kuhn, by Dave Marsland of Cardiff Theosophical Society. In The Structure of Scientific Revolutions, Thomas Kuhn presents a compelling framework for understanding the evolution of scientific paradigms, which he defines as the universally recognized scientific achievements that, for a time, provide model problems and solutions to a community of practitioners. Kuhn's thesis posits that scientific progress is not a linear accumulation of knowledge. Rather, it is characterized by a series of paradigm shifts that fundamentally alter the conceptual landscape of scientific inquiry. Kuhn begins by delineating the concept of a paradigm, emphasizing its role in shaping the methodologies and theoretical frameworks within which scientists operate. He argues that paradigms dictate what constitutes legitimate research and guide the interpretation of data, thereby influencing the trajectory of scientific development. This notion is particularly significant when considering the interplay between metaphysical ideas and scientific thought, as it suggests that underlying philosophical assumptions can profoundly affect the direction of scientific inquiry. The author further elaborates on the concept of normal science, which refers to the routine work of scientists operating within a prevailing paradigm. During this phase, scientists engage in puzzle-solving activities that reinforce the established framework. However, Kuhn notes that anomalies, observations or results that cannot be recognized with the existing paradigm, begin to accumulate over time. These anomalies challenge the status quo and serve as catalysts for scientific revolutions, prompting a re-evaluation of the foundational principles that underpin the prevailing paradigm. As anomalies mount, a state of crisis ensues, wherein the scientific community grapples with the inadequacies of the existing paradigm. Kuhn asserts that this crisis is essential for fostering revolutionary change, as it compels scientists to explore alternative frameworks. The transition from one paradigm to another is not merely a matter of accumulating evidence. Rather, it involves a profound shift in worldview, often accompanied by resistance from proponents of the old paradigm. This resistance underscores the deeply entrenched nature of metaphysical assumptions that can hinder the acceptance of new ideas. Kuhn's analysis invites a critical examination of how metaphysical ideas infiltrate and influence scientific paradigms. For instance, the transition from Newtonian mechanics to Einstein's theory of relativity exemplifies how metaphysical considerations regarding the nature of space and time prompted a radical rethinking of physical laws. Such shifts illustrate that scientific revolutions are not solely driven by empirical data, but are also profoundly shaped by the philosophical underpinnings that inform scientific discourse. In conclusion, Kuhn's work elucidates the intricate relationship between metaphysical ideas and scientific paradigms, highlighting the cyclical nature of scientific progress. The implications of his analysis extend beyond the confines of historical inquiry, suggesting that contemporary scientific thought remains susceptible to the influences of underlying metaphysical assumptions. As modern science continues to grapple with complex phenomena, the integration of metaphysical considerations may prove essential for fostering innovative paradigms that can accommodate the nuances of our evolving understanding of the universe. Thus, Kuhn's insights not only illuminate the historical trajectory of scientific revolutions, but also encourage a reflective engagement with the metaphysical dimensions that continue to shape modern scientific thinking.